Hello dear students, once again welcome back to our channel. In this video we are continuing exercise 7.1. We are starting with the question number 5. It's a big lengthy question but it's quite simple problem. We can move to the question first of all. In a classroom, 4 friends are seated at points A, B, C and D. Chamba and Chameli walk into the class and after observing few minutes, Chamba asked Chameli, don't you think ABCD is a square? Chameli disagrees. Using distance formula, find which of them is correct. We have a clue in the question itself. It is using distance formula. That means, being it is clearly mentioned in the question, 4 points. 4 friends are sitting in 4 points. That means if you join these 4 points, you will get a quadrilateral. When a quadrilateral becomes a square. Okay, and we know the properties of square, that is a square has all the 4 sides are equal. Do you think if you show that only 4 sides are equal, can you conclude that quadrilateral will form a square? Of course no, children. That is the same property, a rhombus also having the same property. If all the sides are equal for that rhombus also. But in order to say that quadrilateral will form a square, we have to prove one more property. Okay, in this topic, that is coordinate geometry, angle property we can consider. Okay, so we have to show that, okay, precisely this quadrilateral will form a square. We have to show that its diagonals are equal. But in case of rhombus, diagonals are perpendicular bisectors, but they are not equal. Okay, so this is the thing. That means you have to show that all sides are equal. That means if you join this AB, see children, in order to get AB, you can easily get the length of AB using distance formula. Okay, and BC, CD and AD. Okay, and you can easily say that if all the 4 sides are equal, so you have to find out its diagonals, that is AC and BD. If that diagonals are also equal, you can conclude that these 4 friends are seating, the points will form a square. Okay, so we can do one by one. Okay, that means using distance formula. Okay, AB, what is AB? We can write a formula for the first time only, that is for this AB only, that is x1 minus x2 whole square plus y2 minus y1 whole square. Understood? Okay, so first of all we should know the points at which that A is sitting, the coordinates we should get. Okay, and for that consider this as x-axis, this as a y-axis. Okay, and here this point A, in order to get the coordinates, from this point A, draw the perpendicular towards x-axis and see that where that perpendicular meets on x-axis, and it's very clear 3. See children, from this point A, draw the perpendicular and it meets at the point 3. So x coordinate is 3 and y coordinate from this point towards the y-axis, so 4. So 3, 4. Okay, and for B, in order to get the coordinates of B, okay, towards the x-axis, that is 6, and in order to get the y coordinate, y-axis, so 6, 7, and the coordinate of C here comes, okay, and here is 9 and y coordinate is 4, 9, 4, and finally the coordinates of D, from this point draw the perpendicular and 6 is the point where that perpendicular meets on x-axis, and from this point towards the y-axis, and 1, 6, 1. So B, we have considered AB first, so x1, y1, and this is x2, y2. Okay, so x1 minus x2 whole square. So square root of 3 minus 6 whole square plus y, here if we are taking x1, it would be better to consider this here as y1, okay, and y2. So y1, here this is the second point, that is 6, 7. So this is x2, y2. This is x1, y1. So y1 comes here. So 4 minus 7. 4 minus 7 whole square. Okay, y1 minus y2. Okay, so this becomes 3 minus 6 is minus 3 whole square plus 3 minus 7 is minus 3 again whole square. or this is equal to root of 3 minus 3 into minus 3 is 9. See, if you square minus quantity as well as the positive quantity, the square will be a positive number. Okay. So 9 plus 9, that is root 18, and this is equal to 3 root 2. Root 18, you can write root of 3 into 3 into 2, 9 into 2. So 9 is further prime factorized as 3 into 3. So 3 root 2. From these two 3's, you can take 1 3 outside. So 3 root 2. Okay. Now we can get BC using the same formula, distance formula. But here you can take here this as x1, y1, this is x2, y2. So x1 minus x2 whole square. So 6 minus 9 whole square plus 7 minus 4 whole square. Okay, that is, you will be getting x1 minus x2, 6 minus 9 whole square plus 7 minus 4 whole square. Okay, so 3 square plus here also 7 minus 4 is 3 square. So root 89 plus 9, that is root 18, that is 3 root 2. We have seen that root 18 is 3 root 2. Okay, and the third point, the line segment, that is CD. CD again using distance formula, that is x1 y1, C is x1 y1 and D is x2 y2. So 9 minus 6 whole square, okay, plus y1 minus 4 minus 1. Here also children, we are getting 3. 9 minus 6 is 3 square plus 4 minus 1 is 3. So again root 18, and this is equal to 3 root 2. And the last one is AD, okay, square root of, okay, this is x1 y1, this is x2 y2, that is 3 minus 6 whole square plus y1 minus y2, 6, 4 minus 1 whole square. Again 3 minus 6 is 3 minus 3 whole square is 9, 4 minus 1 is 3, so 9, so root 18, that is 3 root 2. That means we have seen that all the four sides are equal, but this is not sufficient to conclude that this will form a square. For that I already told, we have to show that the diagonals also equal. That is what we have drawn over here in the figure. Diagonal means the line segment joining two opposite vertices, AC and BD. Okay, but here we have seen that AB equal to BC equal to CD equal to AD. Our next aim is show that whether we are going to check whether AC equal to BD. Okay, the same formula, that is by distance formula, AD equal to, see children, AD diagonal, first diagonal, a square has two diagonals. Okay. So you can take AC, not AD, AC. Okay, so x1, y1, x2, y2. Okay, so 3 minus 9 whole square plus 4 minus 4. 4 minus 4 is 0. Okay, 0. That is root of 3 minus 9 is minus 6 square is 36. 6 square is 36. Okay, so this is equal to 36 and is 4 minus 4 is 0. 0 square means 0 itself. Okay, so 0, that is root 36 is 6. That is the length of AC is 6. We are going to check whether BD also 6 or not. Okay, the second diagonal using the distance formula, that is here x1, y1, b, and this is x2, y2. So 6 minus 6 is 0. 6 minus 6 whole square plus 7 minus 1 whole square, y1 7, y2 1. So here again 0 plus 6 square. 0 plus 6 square means 0 plus 36. Root 36 is 6 itself. Okay, root 36 comes, so this is equal to 6 units. That means we have seen that all the four sides are equal and the diagonals also equal, which means these 4 points, okay, will form a square. Understood? So this is all about the fifth question. Now the sixth question, name the type of the quadrilateral formed, if any, by the following points and give the reason for your answer. Okay, so children, for quadrilateral, we need 4 vertices. We have given in each question, we have 3 sub-questions comes under the 6th problem. Okay, and we have 4 points are there. Okay, and if you join, okay, these 4 points, okay, we will get a quadrilateral. Okay, and we have to check whether which type of quadrilateral formed. Okay, so we have special type of parallelograms are there. Okay, and when a quadrilateral become parallelogram, that's properties of parallelogram we know. Okay, that is opposite sides are equal and parallel. But parallelism we can't apply here in coordinate geometry. Okay, so we will show that that the opposite sides are equal and diagonals are unequal for parallelogram. Understood? And for rectangle, opposite sides are equal but diagonals are also equal. Understood? Okay, but all these are the quadrilaterals. These are the special categories. Okay, so parallelogram we know, rectangle we know, and square. How can we show that this will form a square? We already have seen in the previous question, all sides are equal and diagonals are also equal. Okay, and rhombus, all sides are equal. Okay, if diagonals are unequal, it will become, if all sides are equal, diagonals are unequal, it will be a rhombus. All sides are equal, diagonals are equal, it will be a square. This is the theory part, comes under this 3 sub questions. Okay, so we can check one by one. So we are considering the first question. We have 4 points. Okay, and if you draw and if you mark this as vertex A, B, C, D, we have to find out AB, then BC, then CD, and finally AD. Okay, using the distance formula. Okay, and we have to check whether the diagonal property, isn't it? So we can apply one by one. AB by distance formula, that is square root of x1 minus x2 whole square plus y1 minus y2 whole square. Isn't it? So here x1 y1, A is x1 y1 and this B is x2 y2. So x1 minus x2, x1 minus 1 under the square root minus 1 minus x2, that is 1 whole square plus y1 minus 2 minus y2 is B the coordinate, then its y coordinate is 0 whole square. Okay. So we can solve, that is root of minus 1 minus 1, that is minus 2. Minus 2 square is 2 square, that is 4, plus here minus 2 minus 0 minus 2 and minus 2 its square is plus 4. Okay, so that is you will be getting inside the under square root 4 plus 4 is 8 and this 8 is equal to, you can write this as 2 into 2 into 2 or 2 root 2. From this pair you can take 1 2 outside and this root 2, so 2 root 2 units, that is AB. Now we can check what is BC. So BC by same formula, distance formula, here B become x1 y1, this is x2 y2. Okay, so x1, that is 1 minus minus 1 whole square plus 0 minus 2 whole square, that is 1 minus 1 minus minus of minus 1 plus 1. Okay, that is 2 square plus 0 minus 2, that is minus 2, its square is 2. That is again we will be getting 4 plus 4, that is 8, that is root 8, we have seen that 2 root 2. It is clear, children. Now we come to the third side, that is CD. CD equal to, this is x1 y1, D is x2 y2. So root of minus 1 minus minus 3 whole square plus 2 minus 0 whole square. Okay, y1 minus y2. So minus of minus plus 3. Okay, and minus 1. Minus 1 plus 3 is 2. So 2 square is 4. Here again 2 minus 0 is 2 and its 2 square is 4. So 4 plus 4, 8, root 8 is 2 root 2. 2 root 2 units. And now next comes AD. AB, BC, CD, next come AD. This is x1 y1, this is x2 y2. So under the square root distance formula, minus 1 x1 y1, this is x2 y2. Okay, minus minus 3 whole square plus minus 2, this minus 2, and this is y2 is 0, minus 0. That is, here we have minus 1, minus of minus plus 3. So, minus 1 plus 3 is 2. Okay, 2 square plus here minus 2. Again, we have already seen that 2 square, that is 4 plus 4, 8. Okay, that is equal to 2 root 2. See, after solving this, what we have seen? We have AB equal to BC equal to CD equal to AD. That means all the four sides are equal. So, there is a possibility of either it can be a square or the rhombus. Both having all the four sides are equal. So, in order to decide whether these four vertices will form a square, we have to check whether about its diagonal property. Okay, that means if we have this ABCD, okay, ABCD, we have seen that all these four sides are equal. Now we are going to check about its diagonal AC. And next we have to check BD. If the diagonals also equal, you can say that it will form a square. For square, diagonals are equal, but in rhombus, diagonals are perpendicular bisectors, but they are not equal, unequal diagonals for the rhombus. Okay, so this is the way. So that is what I am going to do now. That is, we are going to check that is it's the first diagonal AC by distance formula, that is root of A, that is minus 1 minus 2, that is x1 y1, that is minus 1, C is minus 1, minus of minus 1 plus here y1 minus 2 minus C is 2 whole square. Okay, so this is equal to root of minus 1, minus of minus become plus. So, minus 1 plus 1, that is 0 square plus minus 1 minus 2 minus 4, and its square is 16, minus 4, its square is 16. So, root 16 equal to 4 units. This is AC. Now, the second diagonal BD. BD again we can take B as x1 y1 and D as x2 y2. So, B is 1 comma 0. So, 1 minus x1 minus x2 minus 3 minus of minus 3 whole square plus y1 minus y2 2 minus 0. Okay, sorry, here B is 0 minus 0, that is 0 minus 0 whole square, that is root of minus plus 3 and 1, 3 plus 3 plus 1 is 4 square plus 0 minus 0 is 0. So, 0 square, that is root 16, and its square root is 4 units. What we have seen, we can conclude that we have seen that AB equal to BC equal to CD, and that is equal to AD. That means all sides are equal, and also the diagonals AC equal to BD. That means the given 4 points will form, okay, that vertices of a square. Okay, so ABCD, okay, will form the vertices of a square. Okay, so this is the way to solve the problems. That is, how can we check whether the given 4 points will form the vertices of a which type of the quadrilateral. Okay. Now the second sub question, here also we have 4 points given, okay, and we can treat all these 4 are the vertices of a quadrilateral, and by finding this AB, BC, CD and AD, we can decide, also considering its diagonals, we can say that which type of quadrilateral will these 4 vertices points will form. Okay, so one by one, so let it be A, this is B, C and D. So, first we are going to check what is AB. So, AB by distance formula, okay, AB equal to root of x1 minus x2, that is minus 3 whole square plus y1 5 minus 1 whole square. So, this is equal to, that is root of minus 3 add and give negative sign, that is minus 6 whole square. Minus 6 whole square is 36. Okay. And 4, that is 5 minus 1 is 4. 4 square is 16. Okay, so when you add, you will be getting this is equal to 36 plus 16 is 52. That is root 52. Root 52. Okay, when you prime factorize this 52, see children, 52, 2, here you will have, that is 2, 6, and in 2, 13. That is 2 into 2 into root of 2 into 2 into 13. Or from this 2 you can take 2 root 13. Okay, that is AB. Now we are going to check what is BC, the length of BC by taking B as x1, y1 and C as x2, y2. Okay, so x1, x3 minus 0 whole square plus 1 minus 3 whole square, y1 minus y2 is 3. So this you will get, this is equal to 3 minus 0 is 3, 3 square is 9 plus 1 minus 3 is minus 2 and its square is 4, that is root 13 units. It's a prime number. Okay, so under square root itself. So CD equal to C as x1, y1 and D as x2, y2. 0 minus minus 1 whole square plus, okay, y1 minus y2. 3 minus, y2 is minus 4. Okay, so this is equal to root of 0 minus, means minus of minus plus, anyhow this will be plus 1 whole square is 1, 1 square is 1 itself. So here plus comes, minus of minus, so 3 plus 4 is 7. Okay, 7 square is 49, so it will be 50. 49 plus 1 is 50. So root 50, you know this is root of 5 into 50 into 25 into 2. Okay, that is 25 is 5 into 5 into 2, so 5 root 2. Okay, from both the two, that pair you can take 1 5 outside, so 5 is still in the square root, so 5 root 2. And the last side, that is AD, A as x1 y1 and D as x2 y2. Here x1 minus 3 minus 1. Okay, D is this one, so minus 1 whole square plus 5 minus minus 4 whole square. So here minus of minus plus 1, so minus 3, so minus 2, so minus 2 whole square is 4 plus, here 5 minus of minus plus, so 5 plus 4, that is 9, 9 square is 81. Okay, that is root 85. That is 4 plus 81 is root 85. See children, all the 4 sides are unequal. That means it will form just a quadrilateral. We can't name, it is not a special type of quadrilateral or a parallelogram. Okay, so it will be a quadrilateral, simply a quadrilateral. Okay, if we can see that after solving all the sides are equal or opposite sides are equal, okay, then you can check for the diagonal. But here that case is not applicable because all the 4 sides are unequal. So it will form just a quadrilateral. Okay. Now the last problem, that is third sub question, 4 5 7 6 4 3 and 1 2. These are the vertices of the 4 points. So we can check one by one. This can be A, this is B and C, D. So as usual, AB equal to, we can do here children. So here we have the formula, the same formula, that is distance formula, is applicable for all the 3 because we are finding the sides. Okay, so distance between the 2 vertices, that is A and B. So this is x1 y1, this is x2 y2. So x1 4 minus 7 whole square plus y1 5 minus 6 whole square, that is equal to 4 minus 3. That is 3, 3 square is 9 and 5 minus 1 is 1, minus 1 square is 1, so root 10. Okay, and BC is 7, 6 and 4, 3, so 7 minus 3, so 7 minus 4 whole square plus here 6 is a y1 and 3 is y2, so 6 minus 3 whole square, so you will getting 7 minus 4 is 3, 3 square is 9, okay, 6 minus 3 is 3, 3 square also 9, so root 18. Root 18 is root 3 into 3 into 2, that means this is equal to 3 root 2. 3 root 2. From this pair you can take 1, 3 outside. Okay. Now CD. CD is 4, 3 and 1, 2 as the vertices. Okay. So x1 minus x2, 4 minus 1 whole square plus 3 minus 2, y1 minus y2, 3 minus 2 whole square, that is 4 minus 1 is 3, 3 square is 9. Okay. 9 plus 3 minus 2 is 1, 1 square is 1, that is root 10. And last side, that is AD. So x1 y1 is A and x2 y2 is D. So which means 4 minus 1 whole square plus y1 5 minus 2. See children, 2 is y2 whole square. So this is equal to 3. 4 minus 1 is 3. 3 square is 9. Plus 5 minus 2 also 9. Sorry, 3 square is 9. So root 18 comes. So this is equal to 3 root 2. 9 into 2 is 18. So 3 root 2 is AD. So children, after getting this length of the 4 line segments, you can see that AB equal to, see if this will be the quadrilateral, and if you are naming like this AB, CD, okay. See what we have seen, how can we mark this children? AB equal to root 10, BC equal to 3 root 2, okay, 3 root 2, and CD equal to root 10, okay, and AD equal to 3 root 2. That means you can see that opposite sides are, okay, that is AD equal to BC, both are equal to 3 root 2, and AB and its opposite side is DC, both are equal to root 10, and AB equal to DC or CD, opposite sides are equal. Okay, so it can be a rectangle or parallelogram. Okay, in parallelogram also opposite sides are equal. Okay, then how can we say that this will be a parallelogram, or how can we justify, how can you conclude? By only after getting the diagonal AC and BD. If diagonals are equal only for the rectangle. In rectangle and parallelogram, rectangle having the two diagonals having equal length. Okay, and for parallelogram, diagonals bisect each other but they are unequal. Okay, so to conclude whether it form a rectangle or parallelogram, we have to check its length of the diagonal, that is AC. Using the distance formula, AC here, A is 4, 5 and 4, 3. So 4 minus 4. Okay, 4 minus 4, x1 minus x2 whole square plus y1 minus y2. Here 5 minus 3. 5 minus 3 whole square. So this is 4 minus 4 is 0. 0 square is 0. Plus 5 minus 3 is 2. 2 square is 4. That is 2 units. And BD. Okay, BD equal to B as x1 y1 and D as x2 y2. So 7 and 6. So 7 minus y1 1. X2, x1 minus x2 whole square plus here 6 minus 2. 6 minus 2 y2 whole square. Okay, so you will have 7 minus 1 is 6, 6 square is 36 plus this is 6 and this will form 4, 4 square is 16 and this is equal to root 52. What we have seen children, here the diagonals are unequal since AC is not equal to BD and this holds, that is opposite sides are equal, which means these 4 points are the vertices of a parallelogram. Okay, this will form vertices of a parallelogram. The reason is clear children. Now the 7th question, find the point on the x-axis which is equidistant from the points 2, minus 5 and minus 2, 9. Okay, so this is very important question, children. See, here we have to find out a point on the x-axis. Okay, and that point is equidistant from 2 points. So this is, suppose this is x-axis. Okay, we should get a point on the x-axis. Let it be x, the p is a point on x-axis. And we know that what is the general form of any point which lies on the x-axis? On the x-axis means x comma 0, y coordinate is 0. So x comma 0, if a point lies on the y-axis, 0 comma y, its x coordinate will be 0. Since the point is on the x-axis, its coordinate is x comma 0. And this point is equidistant from these 2 points. Okay, you need not consider about the which quadrant. We just have an idea about this equidistant idea. Okay, for that, let it be A of 2 minus 5 and the second point is B of minus 2, 9. Okay, and we should get this A is equidistant from P. It is given. And also B also equidistant from P. Or can you write PA equal to PB? What is the reason? Because P is equidistant from 2 points A and B. So this is the idea, children. Always if the word equidistant means you can write PA equal to PB, depends on the points which you are giving for the given points. Okay, that is by distance formula you can easily get the length of AB. Not AB, that is PB and PA. Okay, so by distance formula, okay, you will be getting root of x1 minus x2 whole square. x1 is here, this is x1 y1, this is x2 y2. But in PB, this is x1 y1, this is x2 y2. Okay, that is x minus 2 whole square plus 0 minus minus y whole square. Okay, y1 minus y2, and this is equal to PB, same formula, distance formula, square root of x1 minus x2, x minus minus 2, x minus minus 2 whole square plus 0 minus 9 whole square. See, in both sides we can see the square root. So in order to eliminate the square root, we can squaring on both sides. Okay, we can square on both sides. We get x minus 2 whole square plus, see children, minus of minus become plus, so 5 square is 25 equal to, here after squaring that square root get cancelled and minus of minus 2, that is plus 2. So x plus 2 whole square plus minus 9 square. Okay, that is 81. Minus 9 square means plus 9 square, that is 81. 9 square is 81. So see, after squaring on both sides, see you have x minus 2 whole square, here x plus 2 whole square. So these two terms can be expanded using identities, that is a minus b whole square and here a plus b whole square. Okay, and we are applying that one, that is a square x square plus b square, that is 4, 2 square is 4 minus 2ab, 2 into x into 2, 2ab plus 25 constant equal to, this side also a plus b whole square, x square plus 4 plus 2ab, 2 into x into 2 plus the constant 81. Now see, in both sides x square and x square, when x square come to this side, that get cancelled. So x square get cancelled. Now we have the constant 4 and here 25 comes. So 4 and 25 means plus 4, 25 is 29 plus 29. Okay, and here this term can be simplified, that is minus 2, 2 into x into 2, 2 2s are 4 and minus here, okay, and 4x, minus 4x, and it's okay children. And this is all about the LHS, and in the RHS, come to RHS, here 2 into x into 2, 2 2s are 4 into x, 4x, and here 4 plus 81 can be simplified constant, so 85 plus 4x, this is 4x. These are unlike, we can't add, okay. So, we need the value of x in order to get the coordinates of the point P which lies on the x-axis. We need only x because y is always constant, that is 0. So, our aim is to get the value of x, that will give the coordinate of P of x comma 0. Okay. So, for that I am taking this x term into LHS. Minus 4x is there, minus 4x, then positive come to LHS minus. Here 85, then 29 come to LHS, so minus 29. So 85 minus 29. Okay. So minus 4x is minus 8x equal to 85 minus 29. 85 minus 29 is 6 and 5, 56, positive 56, positive. And x is equal to 56 minus 8, okay, that means minus 7. That means we have seen that the x value is minus 7, means P of x comma 0, this is the required point on the x-axis, equal to P of minus 7, 0. So this is that point which lies on the x-axis, equidistant from 2 points to minus 5 and minus to 9. It's very important problem. So the remaining problems, that is 8, 9 and 10, we will solve in the next video. So thank you children, thank you for watching and supporting my channel. Thank you all.